Hi, my name is Steve Singh, and today I'll be giving you a demonstration of Lab 4, vapor pressure of volatile compounds. Prior to starting our lab, let's take a look at a few of the safety notes. Lab coats and safety goggles must be worn at all times in the laboratory. As we'll be dealing with two toxic and flammable compounds in the form of ethanol and methanol, these chemicals should be handled with extreme care. Moreover, methanol cannot be disposed down the sink. Thus, proper disposal procedures must be followed. In this lab, we'll take a look at the relationship between temperature and vapor pressure for two volatile compounds, namely ethanol and methanol. Vapor pressure is the pressure produced by the vapor phase, which is in its thermodynamic equilibrium with its liquid phase in a closed container. We can thus use the Clausius-Clapeyron equation to find the enthalpy of vaporization, and we can use this data to extrapolate to the boiling point of these two chemicals at various conditions. Prior to starting our lab, let's take a look at the materials that will be used. Over here, we have the methanol and ethanol, then the tub which will act as the water bath container in the conditions of ice water, room temperature water, and hot water. Then we have our temperature probe, our 125 milliliter flask with valve and locking port for syringe. Then we have our 10 milliliter syringe, our Pasco 850 interface with the thermometer and pressure sensor, and finally our computer for data logging. To begin our experiment, we need to create our water bath. Now in this lab, we will be using our water bath at three different conditions, namely ice water, room temperature water, and hot water. For this demonstration, we have chosen hot water. Once we have created our water bath, we can now place the 125 milliliter flask and the temperature probe into it. When we are placing our flask into the water bath, care must be taken that the top of the flask is not under the level of the water. Next, we must open the valve on the stopper on the 125 milliliter flask by placing it into a vertical position, just like this. Care must also be taken that this port should not be rotated. After we have opened the valve, we now go onto our computer and start data logging. This will record the temperature and pressure inside the flask. Once the temperature and pressure has stabilized, we now go back to our flask, and now we close our port by putting it into the horizontal position. Next, we'll be drawing 3 milliliters of the volatile compound into this syringe. For this demonstration purposes, we'll be using ethanol. It should be noted that when you're drawing methanol into the syringe, this procedure should be done under the fume hood, as methanol can be very toxic. Additionally, you should be using gloves for this stage. Now let's draw 3 milliliters of the volatile component into the syringe. To be precise, you should also make sure that there are no air bubbles left in the syringe. Once we have drawn 3 milliliters of the volatile compound into the syringe, we can now screw the syringe tightly on top of the locking port over here. This should be done while the stopper is still in the closed position. So now we'll take our syringe and we'll carefully tighten it on top of the valve locking port. Once we have tightly screwed the syringe on top of the valve locking port, we will now quickly open this valve by putting it in the vertical position. Then we're going to quickly squeeze the volatile compound into the flask. Once we have done that, we're going to quickly pull the syringe back to the 3 milliliter mark and then quickly shut the valve off by putting it back in the horizontal position. Next, we'll carefully remove the syringe from on top of the locking port, being careful that we do not remove this port. And we'll gently shake the valve while still in the water bath to make the pressure and temperature stable. Once the pressure and temperature of the flask are now constant, we can now go over to our data recording and we can stop the data logging. And your pressure versus time graph should look something like this. You now have to repeat the procedures for a water bath of ice water and room temperature water, and repeat these steps using methanol as well.